You're made of atoms. Everything you've touched is atoms. Your phone, your breakfast, your complicated feelings about your landlord. All atoms. Here's the problem. No one has ever seen one. And we still don't fully agree on what seen would even mean at that scale. That's what this video is. Let's start with the oldest answer, which was also a guess. 400 BC. A Greek philosopher named Democritus had a thought experiment. Take a piece of cheese, cut it in half, cut that half in half. Keep cutting. At some point, do you run out of cheese to cut? He said yes. He called the smallest possible piece atomos, Greek for uncuttable. He had zero evidence. He just thought it followed logically. He also thought the soul was made of atoms. Round ones, very smooth, good for thinking. So, philosophy, not physics. Nobody believed him anyway. Aristotle said matter was continuous. No smallest piece. Just infinite cheese all the way down. Aristotle was wrong, but he was famous, so his answer won for 2,000 years. Then came 1803. An English chemist named John Dalton started noticing something strange about chemical reactions. Hydrogen and oxygen combine to make water in the same exact ratio every time. Not roughly. Exactly, 1:8 by mass. Every single experiment. If matter were a smooth, continuous thing, that shouldn't happen. But if matter came in tiny fixed units, identical discrete building blocks, the math works perfectly. So Dalton proposed atoms. Not because he saw them, because the ratios demanded them. That's the first real evidence for atoms, not from looking, from counting, from noticing that chemicals are weirdly consistent. So we have the atom. Small, solid, indivisible. Tiny billiard balls of matter. Fine. Except in 1897, J.J. Justin chimered electricity through a gas and found something coming off the atoms. Tiny, negatively charged bits. Electrons, which meant atoms had parts and weren't indivisible. Thomson imagined the atom as a blob of positive charge with electrons stuck in it like raisins in a pudding. This is the plum pudding model. It is exactly as undignified as it sounds. It was also wrong. Rutherford fixed that in 1909. He fired small, heavy, positively charged particles at a sheet of gold foil, expected gentle deflections. Plum pudding physics. Most particles went straight through, but some bounced almost directly backward. He said it was like firing artillery shells at tissue paper and having them come back and hit you. It meant almost all the atom's mass was squeezed into a tiny, dense core, the nucleus. The rest was empty space. An atom is about 99,9999997.5 feint. The solid world is mostly a structural illusion held together by forces. Then Bohr figured out that electrons don't just float around the nucleus randomly. They exist only in specific, fixed orbits. Specific energy levels. If you give an electron enough energy, it jumps to a higher orbit. When it drops back, it releases that energy as light. The exact colors of light atoms emit. Those bright glowing lines chemists had been measuring for decades without understanding come directly from electrons jumping between levels. The model explained measurements nobody had been able to explain. Again, no one saw the orbits, they inferred them from light, and then the quantum model arrived and made everything philosophically uncomfortable. Electrons don't have fixed positions, they have probability clouds, a region of space where the electron is likely to be found if you measure it. Before you measure, the electron isn't exactly anywhere. It exists as a smeared mathematical object, describing the odds of finding it somewhere. This is not a metaphor for ignorance. This is what the equations say. This is what every experiment confirms. The atom at its actual core is not a tiny solar system. It's a set of probabilities wearing a periodic table costume. So, in 1989, IBM engineers used a scanning tunneling microscope to push 35 xenon atoms into the shape of 3 letters, IBM. You've probably seen the image. Little bumps on a dark surface. Proof we can see atoms. Except here's the thing. A scanning tunneling microscope doesn't take pictures. It drags a needle, so sharp it ends in a single atom, across the surface and measures changes in electrical current. The bumps in the image are reconstructed from those current readings. No light from the atom hit your eye. What you see is a graph of interactions processed and converted into a shape your visual cortex can interpret. Is that seeing? And here's where the question becomes genuinely unresolved. In physics, there's an actual ongoing debate about what real means for objects you can only access through measurement and inference. One position, atoms are real because every model built on that assumption makes correct predictions. Antibiotics, semiconductors, GPS, nuclear energy. The predictions are too precise and too consistent to be a coincidence. Another position, we only know the model. We don't know what the model corresponds to. An atom with no fixed position, no definite state until measured, existing as a probability cloud that doesn't look like any object in ordinary experience. Maybe asking if it's real in the way a chair is real is the wrong question. Democritus cut the cheese and got the name right. Dalton counted ratios and got the evidence. Thomson, Rutherford, and Bohr kept tearing the model apart and rebuilding it. Each time the atom got smaller, stranger, and less like a thing you could hold, science has a working model. The model works extraordinarily well. What it corresponds to underneath the math, that part is still open. Which is exactly the kind of answer Aristotle hated and Democritus probably would have found hilarious.